Hello my dear students, this is Akash HD. Welcome to the ASD physics classes. Hope so you all are doing really great. So students, in this video we are going to solve the question from the chapter Electromagnetic Induction. Okay, so let's go through the question. Question is, a long solenoid of diameter 0.1 meter has 2 into 10 to the power 4 turns per meter. At the center of solenoid, a coil of 100 turns and radius 0.01 meter is placed with its axis coinciding with the solenoid axis. You can get the idea from the diagram also. The current in the solenoid reduces at a constant rate to 0 ampere from 4 ampere in 0.05 second. If the resistance of the coil is 10 pi square ohm, the total charge flowing through the coil during this time is how much here? Okay, so if we talk about here in this question, they are talking about first one, solenoid here. And which kind of solenoid is there? Long solenoid is there. Okay, that means we can tell infinite length solenoid. And second thing, they are talking about here the coil. Okay, so one by one we will take the things. So first one I am going to take the solenoid. Which solenoid is there? As I told you, long solenoid. And the magnetic field inside the long solenoid formula is mu naught Ni in a air medium. It is independent of the radius of the solenoid. That means this data, there is the no use here. Okay, this data no use. Okay, so see here please. So I am going to write here. See here, diameter is given here what? Anyhow no use, but I will write here 0.1 meter. This thing we are writing for the solenoid. Okay. After that, how many turns are there? You can see very well. The number of turns per unit length, that means small n value, is given how much? See, 2 into 10 to the power 4. And this is what? Turns per meter. If in case it is given turns per centimeter, we have to convert. But here, they have not given. No problem. After that, see, again, let's take here again about the solenoid. The current decreases from where? 0 ampere from 4 ampere. That means what is the initial current in a solenoid? You can see very well 4 ampere. And after that, how much current is there? In a solenoid, the current is 0 ampere from 4 ampere to 0 ampere. Okay, and you can see very well this pink color is what? Solenoid is there, and here current is there, I represented by the blue color. Okay. After that, what is the time is given here? Time is given 0.05 second is there. Okay, time interval what is given here? 0.05 second. This thing is all about the solenoid. After that, you can see very well at the, or we can tell inside the solenoid what is there? One coil is there. Okay, so for this coil, now we are going to write down the data for the coil. Okay, so for the coil, what is given here? Let's see. Coil is having how many turns? 100 turns is there for this small coil. The number of turns is given here 100. This data is there. After that, the radius of this coil, no? The radius of this coil, no? Because you can see cross-sectional area of the coil and the cross-sectional area of the solenoid, both are parallel to each other. Okay, so the radius what is given here? Let's take here the radius of the coil. It is given here 0.01 meter, or I can write here 10 to the power minus 2 meter. After that, you can see here the resistance of the coil is also given here. Okay, so resistance of the coil what is given here? Let's take here 10 pi square ohm. Okay, so here this pink color represents the data of the solenoid and this red color represents the data of the coil. Okay, so now we have to see how much charge will flow. You can see very well this solenoid will generate the magnetic field, and for the infinite length solenoid, what will happen? The magnetic field will be uniform. Okay, and that change of magnetic field will generate change of flux, and due to change of flux, the induced charge will come, that we have to calculate it. Okay, so this data and all we have written that. Now we'll write here for coil here. Okay, this is for coil. We are seeing for coil. Okay, so you know very well for coil, I equal to dq by dt. Is it? Very basic we are going to do now. So charge dq equal to I into dt, integration. So now I can write here integration of dq is equal to I. What is the I? I you know very well, induced EMF by resistance into dt. Now we can write here, see, integration of dq is equal to 1 by r is constant, and from the Faraday's law, second law, what is the EMF? You know very well, minus n into d phi by dt and into dt. Now what will happen that here, this dt and this dt cancelled, okay. So we can write here, see, integration of dq is equal to minus n by r, and this will become here integration of d phi. Now, so if I will put here the, let's take initial charge q1, flux is what is there, phi 1, okay, and let's take here final charge is q2, and flux what is there, phi 2, okay. And let me see here how the current I have written, I initial, I final. Now, so instead of this q1, q2, what I will write here? I will write here I and F denotation. That will be better, because there I have written here water, there I have written this one, I, F. Here also what is there here? I, F. Now this is better. So after that, what this will happen that here, see here, when you will integrate and you will put the value of qf and qy, this will become here delta q is equal to, here let's see here, minus n by r into, this will become what? Delta phi. That means phi f minus phi I. Okay. So now we can write here, see, this charge flow is minus n by r, and delta phi means phi final minus phi initial. Is it? Now let's see which flux will be 0. You know very well, flux means magnetic field and the area. See here please, if I write here the general formula, flux is given here magnetic field into area, BA cos theta, but here in this situation the theta will be 0 degree, because I told you area of cross section of coil and solenoid is parallel to each other. Okay, so this will be BA, and what is the magnetic field formula of the solenoid? Mu naught Ni, okay, and area I can write here pi r square. So from here you can see very well, this flux depends upon the current, is it? And you know very well what is their final current is 0. That means what about the, see here, the final current is 0. That means final flux will be also 0. Okay, so I can write here this final flux will be how much? 0. So we can write here, see, minus n by r, this will be 0 minus phi initial. So from here this will become here, see, n by r, and here phi initial. Okay, so this is the formula, we have got it. Now we have to just put here the values after simplification. If we will do one more steps of simplification, we can write here, see, this delta q equal to what? N by r. Flux means magnetic field, B into A, as I told you, and what is the magnetic field? See, mu naught n and initial current. Is it? This is the magnetic field. Area of cross section of the coil, what is given here? Let's take here pi r square. This is the thing, is it? So now we have to just put here the data, things are over. So see here, the number of turns in a coil, capital N is what? The number of turns in the coil. What is the number of turns in the coil? You can see 100. If we remember the data, that is better. So see here, please, here 100 by resistance. What is given here? See here, the resistance of the coil is given here 10 pi square. Okay, so let me write here, see, 10 pi square into mu naught value, we know very well, 4 pi into 10 to the power minus 7. Okay. After that, what will happen that here? What is the small n value? Number of turns per unit length, 2 into 10 to the power 4 for the solenoid is there. Okay. So see, 2 into 10 to the power 4. Now, initial current, what is given here? I initial is given here what? 4 ampere. Initially the current is 4 ampere. So 4 into, after that, pi r square. So this is pi into small r value, what is given here? Radius of the coil 10 to the power minus 2. We'll take here the square. So this will become here 10 to the power minus 4. Okay. This is the 10 to the power minus 4. So let's see here what are the things can be cancelled out. So you can see very well, this pi and this pi is cancelled by this pi square. Okay. After that, see, this 10 to the power 4 is cancelled by this 10 to the power minus 4. Okay. Then what will happen that here? Let's see here. This 0 is cancelled by this 0. So now you can see here, if we'll write here, see, this is the 4, this is the 2, this is the 4. So 4 is 16. 16 into 2, 32. 32 into, let's see here, the 10. So this is 10 to the power minus 7 and here 10. So this will become here 10 to the power minus 6 coulomb. 10 to the power minus 6 coulomb, how much here? Microcoulomb. That means we can write here this delta Q charge flow will be what here? 32 microcoulomb. Okay, can you see here? Okay, so let's see which one is the correct option. 32 microcoulomb. The correct option is the option B is the answer. Okay, so students, I hope so this question based upon the solenoid and the coil is very clear to you. Keep studying, keep going.